Welcome to new teaching and training in electric vehicle vocational educational training. Today we are going to talk about high voltage electric vehicles. First of all, we need to discuss what is a high voltage electric vehicle. It comes according to the ECE R100 when the voltage that is used in the car is over 30 volts AC or over 60 volts DC, then we talk about high voltage electric vehicles. But why do we use high voltages? It's very easy to answer. The power comes from either the current or the voltage, and if you want to use higher current, you need to have stronger cables, thicker cables, or you can use a higher voltage, then you can spare some cable money, and it's also easier to store higher voltages than to produce higher currents. That's why we use higher voltages to increase the outcoming power. What components do we need for a high voltage electric vehicle? The basic structure of each HV system is the same. We need to have a battery. We need to have one or two or more electric motors and a generator or two generators. We need to have an inverter and a DC-DC converter or several converters. We need to have an ECU, an electronic control unit, of course, a charger and the charging plug connector, and we need to have some further high voltage units like compressors or anything like this. High voltage electric vehicles are classified into 5 different columns: micro hybrid, mild hybrid, full hybrid, plug-in hybrid, and electric vehicles. Some also call fuel cell vehicles to the high voltage electric vehicles, but we don't want to focus on these cars in this presentation. So let's have a look at the micro hybrid vehicles. Micro hybrid vehicles do not drive electrically. They are called hybrid vehicles because they have a start-stop function for the combustion engine, and the energy that is needed for this function comes from recuperation, and that's why they are called hybrid vehicles. But you cannot drive electrically. The construction is rather simple. You need to have a classic starter or an IMG, an integrated motor generator, with up to 4 kilowatts and a lead acid battery, of course. The voltage range is, because it's not a high voltage car, the 12 volt nominal voltage that we already know from other cars. The fuel saving is up to 5%. The industry says, well, it depends on how many start-stop situations you have. 2 to 3% is more realistic. And the classic example for micro hybrid vehicle is a BMW 1 Series car. A mild hybrid vehicle is the first vehicle you can actually drive with electrically, so it has also a start-stop function for the combustion engine, but it also has a battery that is used for driving and an electric motor that is used for driving, but it can only drive short distances and only up to 50 kilometers per hour, so it's more used for boosting the combustion engine, and it's mostly constructed as a parallel hybrid car. The energy storage is below 20 kilowatts and the motor generator power is also below 15 kilowatts, just for boosting the combustion engine. The voltage range is rather low, between 42 and 160 volts. The fuel saving is up to 15%, depends on how much you can drive electrically. A classic example is the Honda Insight from 2009. A full hybrid vehicle is a car you can drive with more than 50 kilometers and per hour, of course, and it also has a start-stop function for the combustion engine, and it uses recuperation for the driving battery, and it boosts also the combustion engine. It is constructed as a parallel or a serial or a power split hybrid, and the energy storage is higher than 20 kilowatts, and also the motor generator produces a higher power than 15 kilowatts. The voltage range is up to 350 volts, and the fuel saving is, depending on how you drive the car, up to 30%. A classic example is the Ford Mondeo hybrid. If you want to drive greater distances or higher speed or at higher speeds, then you need to have a plug-in full hybrid vehicle, which comes with functions like start-stop for the combustion engine, of course, and recuperation for the driving battery, of course, boosting the combustion engine. But you can drive electrically more than 50 kilometers per hour and about medium distances. It is constructed as a parallel or a serial or a power split hybrid, and the energy storage is above 20 kilowatts, and the motor generator, of course, is higher than 15 kilowatts. It's about 50 kilowatts that is useful. The voltage range is also up to 350 volts, and the fuel saving is, depending on the distances you want to travel with the car, more than 30%. Classic example is the Volvo V60 Recharge. And at last, we want to look at the electric vehicles. The function is clear. You drive only electrically. You do not have a combustion engine in this car. And of course, these cars can also use recuperation for the driving battery. It is constructed with one or more electric motors and with at least one motor generator with definitely higher power than 15 kilowatt, and the electric storage also is much higher than 20 kilowatts. The voltage range is depending on what kind of car it is, what is the purpose of the car, and goes up to 850 volts at the moment. And we do not talk about fuel savings because you do not burn any fossil fuels in this car. And the classic example is the Mercedes-Benz EQB. That is about classification of hybrid and electric vehicles. Thank you very much for your attention.